Hey, welcome to class 5. So this is week 3 and either Monday or Tuesday, depending on which section you're in. And what I want to do in today's class is do a quick review on some of the concepts around C programming. And my goal is not to teach C from the ground up. Again, everybody in here should have completed CSE 121. And I posted some resources earlier online that you can use to go through some tutorials on C, do some practice exercises, and so on. So what I want to do here is just kind of go over some of the things that we don't necessarily need to know about C to be able to write programs, but I think it's useful to know with an eye towards moving into, much more complex programming in winter term when we start working with data structures. And we're going to work a lot with what's called a hello world, and a hello world is just a very simple program that that does the bare minimum to give you a working program. So for example, I'm sitting on my Linux server account, and I'm just going to make a program main.c. We've done this before, so we'll do our usual include. We'll declare the main program, and then we'll just have a print statement. And so this is one line of executable code, one line describing the name of the program and of the function, and our usual include. And if I just say gcc main.c, oh, I forgot my semicolon, of course, because that always happens. So go ahead and compile main.c, and if you do an ls, you'll see an a.out. That's your executable program, right? This is the source program, the one that contains the source code. This is the program you can run, and if you just say a.out, it runs your program. So that's what we mean by a hello world, and every language has, its own version of a hello world. If you work with a more complex package, if you work with a piece of hardware like an Arduino, there's usually something equivalent to a hello world. For an Arduino, it's, a configuration that lets you make an LED blink. So it's a simple piece of code that we can use to start, building up more complexity from. So there's a really large problem set that we're going to work through in class that's going to have you do a number of things. But one of the things we're going to do is play with this idea of compiling a program. If we say gcc main.c, it always creates an output called a.out. And if I make a new program, let me call it main2.c. And I compile main2.c. Right now my program says testing 1, 2, 3, but my compiled version of main is gone, right? Because that was also called a.out. You can only have one a.out in a given directory. So we use a switch, right? This thing that we can put after our command with a dash, like -o, to specify what the output file should be. So normally if I just say gcc main.c, the output file, the file that's created, is a.out. I could say gcc-o main.c, and that says, hey, don't make an a.out, make something called main instead. So let me remove a.out, and let me say gcc-o main.c, and now you can see I've got this program main, and that's the executable version of main.c. And if I say gcc-o main2.c, I've got two programs, main and main2. And main is still the original program that says hello world, but main2 says testing 1, 2, 3. So you don't really want every program that you write to always be called a.out as an executable. So we can use this -o switch. And there are, a zillion switches we can put on the gcc command. If I do a man on gcc, you start to see some of the switches up here in the synopsis -o output file. But, if you go through here, there are a lot of switches you can put on this command. But -o is a pretty useful one. So we're going to play with some other ones in the practice problems. We're going to play with -C, we're going to play with -S, and so on. And we'll get plenty of opportunity to explore the GCC command more fully. The next thing I want to talk about is strings. And so, you know, a string is something like, quote, hello. It's a series of characters, usually written inside double quotation marks. And we could have, you know, just a single character like X, but this is still a string because it's sitting inside double quotation marks. That's different from if I put something inside single quotation marks. This is a character. This is a string. So for strings, we're always going to think about double quotes. And with C, the way that strings are stored is simply with an array, and in particular an array of characters. So if I have a string like hello, it's actually a collection of 5 characters. First the letter H, then the letter E, the letter L, another letter L, and the letter O. And if I have a string like X, that's just stored as a single character X. Now when we have an array, and we'll talk about arrays in the next lecture, but when we have an array, basically, you know, we can index each element by using square brackets, and our indexes start at 0. And so the first letter of our string is stored at the first element of our array, the second letter is in the second element, and so on and so forth. So if we want to declare an array, we can do something like this. So let's say character string, and I'll make an array that can hold 20 characters. So let me start adding some comments on here. This string can hold 20 chars. So how do I give a value to a string? Well, one way is to use a function called string copy. And string copy comes from our string.h library. And if you look at the man page for string copy, you can see it takes 2 arguments, a destination string and a source string. And string copy copies a string pointed to by source into the buffer pointed to by destination. So what does that mean? If I want to copy the word hello into my string, I can just say string copy string, comma, quote, hello. So that copies the string hello into the variable named string. And that means that, you know, this string is somehow a collection of memory locations, one after another, containing the letters H, E, L, L, and O. And once we have a string, we can do all kinds of things with it. For example, we could say printf string equals, and we could say %s. And when we use a %s with a printf, it means treat this thing as a string, an array of characters, and print out each of those characters one after another. So if I compile that, and I run main, it tells me string equals hello. Alright, and there's a lot of functions we can use in this string library, including things for finding the length of a string, things for comparing strings, and so on. And we'll work with those in the practice problems. But I want to look in here at this idea that this variable string is actually an array, right? We said up here it's an array of 20 characters. So let's see what's in this array. Let's just make a for loop. And I'm going to use, you know, a slightly fancy version of a print statement here. I'm going to say I goes from 1 to 20. I'm going to say character, and I'm going to print out the value of I is, and then I'm going to print out the value of the ith element in that array. So if I run this, character 0 is H, 1 is E, 2 is L, 3 is L, 4 is O. That's exactly what we were expecting. But after that, things get a little weird. Character 5 is, I don't know, nothing. 6, 7, 8, 9, 10, 11, 12, all of these are apparently nothing. So that's a little bit strange, but let's dig further into that. So instead of printing out a %C, which is a character, let's print out a %D, which is an integer. Now, I told you that a string is an array of characters, but in C, characters are actually the same as really short integers. It's a single 8-bit, 1-byte integer. And so the compiler will be perfectly fine using a %D to print out a string. So let's compile that and run it. And now we can see character 0, 72, 101, 108, 108, 111. And then we have a bunch of zeros. So apparently after HELLO, we have a bunch of zeros in our array. Now that just happens to be the case right now, but that's not always going to be the case. And let me give you an example. So suppose I say something like, this is a long string. I'm going to copy that into my string variable. And then I'm going to recopy hello into my string variable. So what do we think this is going to print out when we run it? Oh, my string's not long enough. So let me just say this is a string. So what do we print out? 72, that was our H, 101 is E, 108 is LL, 111 is O, and then the next character is a 0. And then we start seeing some non-zero things. So let me go back to printing out a %C. And we can see that our string is HELLO followed by this character 0 and then S space A space string. So this stuff is stuff that was already in the string from that first string copy I did. This stuff is in the string from the second string copy. But when I print it, it just says hello. It doesn't say hello S A string. So how does it know that my string ends after the O? It's because of this fifth character here. It's because this character is a 0. So this is what we call the null terminator. And the idea of the null terminator is whenever we have a string like HELLO, there's an extra character added to the end, which we can write as a \0. That's the null terminator. There's nothing magic about that. It's just a convention. We could have decided that, we're going to put a period at the end of each string, and that'll signify the end of the string. But that wouldn't be good because sometimes we want periods inside our strings. So a null terminator is a character that's not a regular letter, it's not a digit, it's not a punctuation mark. So it's pretty safe using that to say this marks the end of the string. And then everything up to there is part of the string. The null terminator marks the end of it. So now we can do something like this. If I set let's get rid of this silly thing in the beginning here. So I'm going to copy hello into my string. And let me do the following oddball thing. String bracket 3 equals null terminator. And let me get rid of this for loop. So I'm going to copy the word hello into my string, and then I'm going to set string bracket 3 equal to a null terminator. And I'm going to print out my string. So what am I doing? After I load this into my string, I'm going to change this to be a \0. And so when I print my string, it should end up being 1, 2, 3 characters long and just contain HEL. So let's compile that and run it. And sure enough, my string is just 3 characters. So strings are nothing more than arrays. They're arrays of characters. The only thing that's unusual about them is they have this null terminator at the end, which tells the system where the string is supposed to end. Alright, so that's the basic deal with strings. Like I say, we're going to play with that a lot in class. So next thing I want to talk about is feeding input to a program, and there's a few ways to do this. The main way we're going to send input into a program while it's running is to use fgets. And the structure of fgets is we have some string. We have an integer which tells us how big the string is. And then we have something saying where do we want to input from. And for us this is always going to be stdin if we want to read from the keyboard. And so let's play with this. So let's just say something. And we'll use fgets to read 20 characters into, so I'll call this string. Doesn't have to be string, it could be any variable name. And then I'll print out the value of string. So I'll run my main program, say something, hello world. And it tells me string equals hello world. And if I say haha, it tells me string equals haha. And if I say 1 plus 2 plus 3, of course string is not going to be 6, it's going to be 1 plus 2 plus 3. And you notice there's an extra blank line coming out here at the end. And if I just type in nothing but the enter key, I still get this extra blank line at the end. So let's put in what's called a delimiter. A delimiter is just some sort of character we can see that we put on either side of a string to help us know where the string begins and ends. So for my delimiter, I'm just going to use a square bracket. So I'm going to say string equals bracket, and then print out the value of the string, and then print out a right bracket. And if I do that, and I say hello, what I get back is string equals bracket, HELLO, and my close bracket is on a new line. So there's an extra character being included here. It's called a new line. It's this thing that we write as \n. And fgets appends a new line to the end of our input. So if I say hello, the string is actually equal to 6 characters, HELLO, and a new line. So that's something that's important to keep in mind. Fgets is the way that we're going to read in a line of input from the user. There's another function called gets. We're never going to use gets. We'll play with it in the practice set, and we'll read about it and work with it, and we'll break it. But we're always going to stick with fgets. And again, fgets, you put in the name of your string, the length of your string, and where you're reading from. And for now, that's always stdin, standard in. All right, you should know about scanf as a way to read input into your program. And so we could say something like this. We can say enter a number, and then we can say scanf %d address of x, and then we can say x equals %d. And I'm going to declare x to be an integer. So what it'll just do, it'll say enter a number, that's what we call a prompt. And then scanf says read from standard in. This says convert the input into an integer, store it in this variable x, and then I'm just going to print it out using a printf statement. And the funny thing about scanf, remember, is you need this ampersand in front of x. We're going to play with that a lot on the next class when we talk about pointers in more detail. But if we compile this, so some shortcuts I'm using here, right? I'm using !vi to get back to my VI session. I'm noticing that I made a mistake on line 9. So when I come in here, I'm going to type a 9 and an uppercase G. That's going to take me right to the line in question. A $sign gets me to the end. I'll say add semicolon escape, colon WQ. And then I'm using an exclamation mark GC to get back to the last time I typed a command with GC. That was my compile line. And then I'm just saying main. So enter a number of 23, x equals 23. So that's how we use scanf, but we're going to end up using something different from scanf. We're going to use what's called sscanf, and we'll see why when we work on some of the practice problems. But we're going to do two things when we want to read something from the user. First, we're going to use fgets, and we're going to say fgets string 20 standard in. And then we're going to use sscanf. And we're going to give it as a first argument the name of that character array, that string. And then we're going to do the rest of what we normally do with scanf, say what the format is and where we want to put the results. And if we do this, right, it's going to work exactly the same, but it's going to be better behaved in the case where there's problems with the input. And we'll see why later on. But this is what we're going to move towards is, well, we want to read something from the user. We're going to do it in two steps. We're going to use fgets to actually read the input, and then we're going to use sscanf to convert it from a string, because fgets always returns a string, into whatever format we want, for example, an integer. All right, and then last thing I want to talk about is argc and argv. And these are somewhat hated by people sometimes, but they're really not that bad. So when you write your main program, you declare this int argc char star star argv. The only thing you have to know about this is when you run your program, let's say your program is called main, I can put one or more things on the same line where I type the name of the program. And each of these things that I put, I can read from inside my C program. Now, how do I read these? I use argc and argv. So argc equals 1, 2, 3, 4, 5, 6. The number of things that I typed on the command line. And argv is an array, but instead of an array of characters, it's an array of strings. And each element of that array is one of the things on my command line. So if I declare my main program with this pair of arguments, an integer and a char star star, this tells me how many things were on the command line. And this is an array of strings. The first element is the first thing on the command line, the second element is the second thing on the command line, and so on. So we'll work with that in some sample code and get some practice with it. But that's going to give us another way to feed input into a program, which is to specify the input on the command line when we specify the name of the program we want to run. And so we're going to differentiate between two ways of feeding information into a program. And I'm going to mention this here because it's going to come up again and again. The first is runtime input. And runtime input means while the program is already running, you give it some information. For example, you've got a program that is going to say, enter your name, and you type in your name, and it says enter your password, and you type in your password, and it says what transaction do you want to make, and you type in some information. Those things that you're typing in while the program's running, those are runtime inputs. And we're going to usually deal with those by using fgets and maybe sscanf and etc. But there's also the possibility of specifying information at the same time that you specify what program you want to run. We do this all the time. We do this, for example, when we say VI. When I want to edit a program, I say VI followed by the name of the program I want to edit. So when we do that, when we put the information on the command line, that's called a command line argument. And that's when we're dealing with argc and argv. And we can do one or the other, or a lot of times we'll do both. So that's just terminology I want to make absolutely sure everybody is crystal clear on. A runtime input is something we put into the program while it's executing. A command line argument is something we put on the command line along with the name of the program that we're about to run. So two very different ways of specifying information to the program. All right, that's it for this C refresher. And next class we're going to dig into more depth on pointers and arrays and how those two concepts relate to each other. And if some of the stuff about strings being arrays and accessing them was a little unclear, it should get more clear with the next lecture. All right, thanks.